find it will help us to find what we are going to study, how to find current voltage by combining resistance. Maybe it will be in series or parallel. So we have just to find if we have to mark it if it is that resistance is in parallel or it is in resistance. So here we have the first example for series resistance. Let's see, here we have the current flowing through this resistance 1, and then just we will continue to the current resistance 2, and then we have resistance 3. It means here we combine three resistance. And then how we just get our resistance equivalent, which we got ref R key. So we will just take the sum of that resistance R1 plus R3 plus R2. Here R1, R2, R3. And then here we just get the equation like this. We have seen that it will come from this circuit with the 3 resistance, and then it becomes as have the 1 resistance. And then let's see how we will just find the voltage. So here just we have this, we just have to find this voltage of all these circuit, and then V it will be equal to the voltage 1 plus voltage 2 plus voltage 3. And then as we replace how the voltage 1 is equal to R1 times this current flowing through this circuit, this resistance, plus R2 times current plus R3 times current. Then here we have this voltage, and then this voltage also total voltage is equal to just R equivalent is what we call R equivalent times current equal to R1 times current, R2 current plus R3 current, and then this current will be removed for both sides, and then remaining with R equivalent equal to R1 plus R2 plus R3. That is what we have get here. We have the parallel resistance. So how we just get it's the total resistance. Let's see, for the here we have 3 parallel resistance. So we see resistance 1, resistance 2, resistance 3, and then we have the for Kirchhoff's current law says that the entering current is equal to the leaving current, and then here we will have the current. This current will have this current 1 plus current 2 plus current 3, because it is leaving at this node. This current will flow here and then form the current 1, and then we will continue in this node and then form current 2, and then we will continue to form current 3. And then what we will get? Then we see this resistance in parallel will share the same voltage. It means current 1 will be equal to voltage over resistance 1 plus voltage over resistance 2 plus here we also have voltage over R3, and then here this current is equal to voltage over total of this voltage, which we call this resistance of equivalent. So R equivalent is equal to, here we will remain with this, let's say this V, because it is on both sides, we will just removed and simplified for both sides, and then we get 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3, and then we get this. We can form the inverse for this and then we get that 1. This, if we take inverse of this, will be R equivalent will be equal to 1 over 1 over 1 R plus 1 over R2 plus 1 over R3, which will give us R1 times R2 times R3 over R1 plus R2 plus R3. Then this is the general formula for R equivalent, and then here we can write down here R1 times R2 times R3 over R1 plus R2 plus R3. This is the general formula for this equation with the resistance in parallel. Here just we have to find equivalent resistance, and then we have this equation, and then this is circuit, and then we just have seen series and parallel. Then this exercise combined together series resistance and the parallel resistance. So here we have just to find which one is in series, which one is in parallel. So we see this R3 is just in series with R4. This will mean it is in series, and then if we use 2/ will mean that it is in parallel, and then we see this and this after being in series, it can give us R equivalent equal to R3 plus R4, and then we get that 5 plus 15 is equal to 20 ohm. And then let's see what figure will remain here. It will remain this equation. Here we will remain with, I'll have 20 ohm. Here there is 20 ohm for resistance 2. Then here we have R1. And then this figure shows us that this R equivalent, it is in parallel with R2. That's what we have just to put in just to combine together. And then we get that R equivalent is equal to R2 plus R equivalent. Here just we have the R equivalent, and then it is many. They say that this is equivalent 1, and then it is equivalent 2. And then this R equivalent 2 will be equal to R2, and then plus R equivalent 1. Then it is R equivalent 2 is equal to 20. Here we just have to take 1 over 20 plus just 1 over 20, and then this will be equal to 20 times 20 over 20 plus 20. Then we get R equivalent equal to 400 over 40. Then we get that the solution here it is 10 ohm. Mainly with this circuit, we have this R resistant 1 equal to 10. Then here we get also R equivalent equal to 10 ohm. Then here we have just the starting circuit, and then here these two current, we see that it is in series. Then here it means that this R1, here there is R equivalent 2, then R equivalent 3. How it will equal? It means here we will get the final equal to R1 plus R equivalent 2, which will be equal to 10 ohm plus 10 ohm, and then here we get 20 ohm. Then it means our equation remains with this. Here we have 20 ohm, and here we have just our equivalent 3, and then we are asked to find this. It means this will be the solution. Just example 2, also to find how we just combine the resistance, and then we get equivalent resistance. Then here what you have to note first, it is just to see which resistance is in parallel, which resistance is in series. and then you start from the side which will just make your circuit simple. Let's see, here we just see how we have R2, R1, R3, R4, and then we see that these R3, it is in parallel with this R4, and then here we see that we will just take this is in parallel with this, and then we just, after combining this, it will make easy this circuit. Then you see how R equivalent here, R equivalent 1 will be equal to R3 times R4 over R3 plus R4. Then equivalent 1 is equal to here 6 times 3 over 6 plus 3. Then we get 18 over here 9. Then this is equal to then let's see the circuit. Let's see the circuit. We will remain with, here it is 8 ohm. Then here we remain with here the 2 ohm. And then here there is resistance 1 also equal to 1. Then here it is, so we remain with this. So let's see this and this, we see that it is in the series, and then it means for this resistance R equivalent 1 and then R2 is in the series, and then we will combine it. R equivalent 2, let's say that will be equal to R2 plus R equivalent 1, then we remain with 8 plus 2 then we get 10 R equivalent 2. Then the circuit will be like this. Here we combine it together. Here there is R1. Here also we have 10 ohm. This and this, we see that it is in parallel, because here there is here there is node, then it will share different current but the same voltage. So how we will find this R equivalent between this resistance? R equivalent 3 will be equal to, here we have this R equivalent 2 times R2 over R2 plus R equivalent 2, which will give us 10 times 10 over 10 plus 10, 100 over 20. Then here we remain with 5 ohm. And then we remain with the circuit like this. Here there is 5 ohm. And then this is R equivalent. We are asked to find this final solution. Yes, here we are going to see the voltage divider and the current divider, and then how can we just apply some formulas. And then here we will just have the voltage for divider, R resistance times current. This current we mark that it is this, and then this current we remember that is equal to the sum of this voltage V1 plus V2 plus V3, and then this maybe it can continue. We will have many resistance, and then we see this is in resistance. We can just apply voltage division principle for the resistance which is connected in series. Then here we have, so we can continue from Vn, then over resistance 1 plus resistance 2 plus resistance 3, continue to Rn. Then this can be general formula for this current. And then we can just say that this is R equivalent. Then we put in that equation, and then we get voltage divider can be equal to resistance times this voltage. We can just say it is V total, voltage total over R equivalent. Then this you can use for voltage division principle. This equation for the current division principle, we can apply this equation for the parallel resistance. Then how can we do? We know that here the R equivalent in parallel is equal to, this is R1, this is R2. Then it means it is R1 times R2 over R1 plus R2. And then what we are going to do for the current division, we know that voltage is equal to, we can say that this is for total resistance, and then we say that will be equal to R equivalent times the current total. Then this is current total. We have this is initial where the current starts for this point, and then we know that will just give us current 1 and current 2. And then we know that current share the same voltage but different current. Current 1 will be equal to this voltage over resistance 1. And then we are going to put in this equation. Let's take this equation and then put this voltage. It is equal to our equivalent times current total over resistance 1. And then how it is equal? Let's replace this R equivalent, which we are given here, which is equal to R1 times R2 over resistance 1 times resistance 1 plus R2, which is that the R equivalent times I total. This is current total. And then let's move, this will simplify by R1, then we may use R2 over R1 plus R2 times current total. Then here also current 2 will be equal to voltage over resistance 2. Then as we replace in that equation, we will get R1 times R2 over R2, R1 plus R2. This will simplify times I total. Then here we get R1 over R2 plus R1 times the current total. Then let's do another equation. To do this circuit, and then we're asked to find Vx, Ix, and then I3. This is I3, we can say is this, then Vx this, and then we are going to find also Ix. So how will we just do this? And then here first we have to put this is in parallel with this side, and then let's just combine together. R equivalent there will be equal to R2 times R3 over, just let's say R1 and R2 because we don't have many, 2 R1 plus R2. Then it is equal to 30 times 60 over 30 plus 60. Then here we get 1,800, and here 90. Then we get here 30 ohm. Then let's just do this. We have the figure which is like this. R1 is equal to 60 ohm. Here we have 30 ohm. Then just we are asked to find how there is Vx equal to 100 voltage, and then we are asked this Vx voltage which is applied in this resistance, and then how will be equal, how the Vx is equal to, we will just have here there is, this is R equivalent for this, the R equivalent over R1 plus R equivalent times voltage initially, where we start there. Then this equation will give us here 30 over 60 plus 30 times initial voltage. Then we get here 3,000 over 90. Then we get this ratio. Then we're going also to find I, we're going to find I free. Here, before going into current free, let's find the current source. Current source will be equal to voltage source over resistance 1 plus that other equivalent we have got. Then this will be equal to 100 over 60 plus 30, and then here we get 100 over 90, which is equal to 10 over 9 ohm. Then let's find this I free. I free, as we have gotten in the equation, will be equal to, we have just to take R1 over R2 plus R1 plus R2. There we have times current source, which will be equal to, how we just do that, 30 over, here we have 60, I will have R1 it is equal to 30 plus R2 it is 60 times current 1, we will get current source is equal to 10 over 9. Then this will give us 30 times over 90 times 10 over 90. Then here we get 30 over 81 ohm. This is current free is equal to 30 ohm over 81 ohm. In fact, we will have to find the Vx here, then you have to find the current free, and then here we have R free, and then here we have R2, and there we have R1. And then let's just find this value. We have just to find R equivalent because this is in parallel with this, and R equivalent for R1 is equal to R1, R2, R3 over R2. Here there is times, and then here there is plus. So we get 30 times 60 over 30 plus 60, which is equal to 180 over 90. Then here we simplify, and then we get here there is 1800, then we remain with 20 ohm. For this other equivalent, and then we remain with this circuit. Here there is voltage source, here there is resistance 1, here they have our equivalent Vx. So we ask it to find Vx using the voltage divider. Say that Vx will be equal to resistance 1 over here the resistance equivalent for this, and then over R1 plus R equivalent times voltage source. Then this will be equal to 20 over 20 plus 60 times 100. Here, and then we remain with 20 times 100 over here we have 80. Let's simplify. Here we get 200 over 8, and then we can simplify by just 8, and then we remain with 25 voltage. Then Vx, we get that it is equal to 25 voltage. Then we are asked to find the Is. And how Is will be equal to, we will just have it is voltage source. It is voltage source over resistance 1 plus R equivalent. Then how will it be equal? We have just is 100 over resistance 1, have it is 60 plus, here we have also R equivalent, we have get is 20, then we get 100 over 80, then we get here simplify by 2, 5 over 4, then you get 5 over 4. This is voltage source. And then we ask to find I3 or so. How I3 will be equal? Using the current divider rule, it will give us, it says that we have R3 will be equal to R2 over R2 plus R3 times the current source. Then it means that we get 30 over here 30 plus resistance 3 is 60 times current 4 over 5 over 3 over 4. Then here we get 150 over, this will give us 90 times 4. Let's simplify here, then we get, after calculating, this is the solution for our asked question I3. For this in example, we are asked to find this current 1. This is the question. So here we see, and this circuit here it is in parallel resistor 3 and resistor 2. And then we just have to find this R equivalent for this side. R equivalent will be equal to R2 times R3 over R2 plus R3. Then this is equal to 30 times 30. 60 times 30 over 60 plus 30 is equal to 800, okay, over 90. That is 20. Then we get here 20 ohm. Then we remain with this equation. I correct. So here for this current divider, say that current 1 is equal to this R equivalent over R1 plus R equivalent times the current source, which is this, and then will give us 20 over R1 is 10 plus 20 times initial it is equal to 15, and then I1 is equal to 20 over 30 times 15. Then we simplify this, we are remaining with 2. I simplify, and then with current 1 is equal to 10 ampere, and then here it is solution.